all for joining. New South Wales curriculum starts next year, and 7 and 9 predominantly, although there are some schools implementing right across 7 through 10, like all in. So yeah, we're just going to have a bit of a chat about that today. My name's Erin Gallagher. I've been with Mathspace for 10 years, and before that I was a teacher for 10 years. And beside me is one of our founders, Milo.
Hey, a lot of familiar names in the chat, so welcome to everyone. Today, we're going to show you some of the brand new textbook that we have built.
A nice print one. A book that is very much not dead.
Yeah, and it's interesting. Erin and I have been kind of chatting about, like, well, where was the moment where we kind of realized that the textbook is still a thing? And by no means do we say the textbook is everything. We're still strong believers in a digital kind of approach and a digital first approach. An aha moment was post-COVID, actually. So during COVID, obviously everyone got thrown in to digital. And so we had a huge uptake of usage and a lot of people using Mathspace for the first time. Then after COVID, when schools started to go back, we saw some of our best schools that use Mathspace a lot. Actually, their usage dropped to not just pre-COVID levels, but even lower. And so we reached out and said, hey, what's going on? Is there anything going on? And like, no, we still love Mathspace. We're using it all the time, but we're actually just printing the worksheets and doing a lot of work offline. And just because we just want to detox the students off digital, I just had a lot of exposure to digital. And that was a bit of an aha moment. And it's something that we've been kind of going through the years thinking about it. One of the areas that you've been working on is the worksheets. So maybe you can talk about how you saw the worksheets developing over time.
Yeah, so if you've been using Mathspace for a while, you'd remember that about 2 years ago, we put worksheets in the product, which was an addition to the interactive questions that were like sort of static questions. And one of the big benefits to that was because there are things that you sort of can't do or is very difficult to do in that interactive step-by-step landscape. Things that are really important to be able to assess a student's ability to understand mathematics, which are the reasoning, the understanding, those sorts of things. Can they explain their thinking? Can they justify? And all of those open-ended questions. And so by adding the worksheets, we're able to add that layer of depth to the questions. And so a lot of that appears in a print book. So it's definitely not dead. There's a place for it. Yeah, absolutely.
And I think that's where we've kind of landed, is this giving teachers options and flexibility. And that's one of the big core beliefs at Mathspace, is that teachers understand their students best and they understand what's best for their classrooms. And so, just giving the teachers the opportunity to dip in and out of technology. And that's one of the early feedback we've been getting, is just just great to be able to have that one resource where I can be online and be offline, whether you're printing worksheets and using just the digital, or, your school likes to have the physical textbooks. So that option is there. So
yeah, so on that, we thought we'd ask you, whereabouts are you on that balance between print and digital? So there's definitely believe that being data-led and data-driven is really important. Using data can really help streamline the way a teacher can address all the needs in a very large, varied classroom. So for me, why print is because I believe so passionately in that. I want to be in as many schools as possible. And for some schools, the only way in is through the funding that they get provided to be able to purchase textbooks. Once we've got textbooks, we can talk about how being able to supplement that with our digital product, and then being data-led and data-driven will be like all the way. So I still think the textbook will be dead at some point. At some point, but maybe not in the next 3 to 5 years.
Yeah, I don't know. I'm starting to question that. I feel like there's going to be a place for it for some people for all the time, and that's okay. Yeah. One of the interesting things in that you'll see today is how having the print has probably forced us to think more about a lot of the open-ended questions. And while we've had them inside Mathspace in the worksheets, we haven't given them as much attention as we have this time around. And I don't know if that's a mindset shift for us as we also build the print. All right, questions coming through.
Yeah, so now that you can see the screen, we can certainly see that we're sort of in that middle ground, somewhere balanced, a little bit leaning towards print, a little bit leaning towards digital, and very few are sort of in that fully immersive digital learning experience, or still over in only print only. So Whilst you're there, we've got another one around your impression of the new maths curriculum for New South Wales. So that's obviously what we want to focus on a bit today. The maths curriculum was sort of published last year, so you may have already seen it. And this may be your first foray because maybe you're new, or maybe this is just the time where you've got headspace to have a look at it. Normally the answers to these are very wide ranging, which is expected because people are all different stages of their new curriculum journey.
Confusing is leading
bold,
way.
yes.
New, it certainly is new. It is actually quite different. And we're talking about the Australian curriculum. Yesterday we did a webinar for those who are adopting the Australian curriculum, and it's been interesting for us just seeing the differences between the New South Wales curriculum and the Australian curriculum. But yeah, there's certainly some crossover words, but there's also some probably new ones here as well.
Yeah. Something that you may not know about the state's curriculum and how its relationship to ACARA and our Australian curriculum. So this ACARA publishes an Australian curriculum, and all of the ministers for education and all of the states at the Melbourne launch of the Melbourne Declaration, actually they all agreed that yes, the Australian curriculum is going to be the way forward, and they all agreed that they would, in their own very varied ways, embody that in full in their own state's curriculum. So even though New South Wales has its own New South Wales curriculum, they are actually, there is an agreement that they will align with the Australian curriculum. So that's why, for example, about 5 years ago, you would have noticed on the New South Wales curriculum site, the ACARA accountability, I suppose, outcomes, the matching outcomes started appearing on the website, because there's that agreement that they'll match it. And that's what I found through the working with both the Australian curriculum and the New South Wales curriculum, is that in this version of both, which are both starting next year, we're sort of more meeting now. It's less varied, and there's sort of a lot of the New South Wales flavour that has come into the Australian curriculum, and also a bit of the Australian curriculum flavour has come into the New South Wales curriculum. So there's some certainly the wide, varied and ranging feelings there. My opinion before we move on of this particular curriculum was that the changes that they've made through stage 4 and then into 5 sort of really tipped the scales in terms of weight towards stage 5. So stage 4, I think, has become more manageable, but stage 5 has become very large. And we'll talk a little bit about that today. Oh, yes.
Yeah, this is the kind of work that Erin does. I just want to take a little chance to shout out. Erin has been with us now for 10 years. She's the longest serving employee at Mathspace outside of the founders. And she was our first curriculum hire, and we haven't really needed, there was no other reason to look anywhere else. But Erin already joined us as a real expert in curriculum. She was the president of the Canberra Maths Association, I think, at the time we poached her. She's just the exposure that Erin has had to curriculum at Mathspace over that 10 years as well, both nationally and interstate in New South Wales, but also internationally. So that exposure to kind of Singapore curriculum, Hong Kong curriculum, the US curriculum, the UK curriculum has really made Erin one of the foremost curriculum experts. And this is what she does. This is when I
the
kind
inside of my brain.
I creep up into the office and it's like, what are you doing, Erin? Post up wall notes on the wall, and how are we going to treat? This one was coordinate geometry, right?
This is New South Wales, actually. The red is stage 4 and the blue is stage 5. Yeah, it's about linear relationships, actually, the development there.
Yeah, how do we make sure the connections are there, and what do we need to make sure? There's some things that maybe are not explicit in the curriculum, but we really need to make sure they're in there so that the development to stage 5 works. Yeah, that was a nice little thing to watch Erin in action.
So that's what we're going to talk about, is actually some of the changes through stage 4 and stage 5, because we're looking at high school and learning maths curriculum. So I've got a few slides here. I've just broadly broken them up into sort of kind of strands, and that's just so it could fit on the screen and make it a little bit more digestible. We're just looking at what's in and what's out. So this is stage 4 first. So we're just looking at what sort of actual content restructuring has occurred. So what's out of stage 4 in number and algebra? The linear equations, the linear relationships, that's that. It's behind me actually. It's the mapping that I just had on that previous slide. They've really slowed that progression of linear relationships through stage 4. So they've pushed anything more than 3 steps of solving equations into stage 5. And in fact, all of stage 4 is really heavily based on tables of values. So you'll see all of the work around identifying an equation comes back to just having the table of values and then being able to pull the relationship from that. Being able to plot, say, straight lines comes from generate a table of values and plot the points. Things like identify if it's linear, but then use that linear relationship that you've got from the table of values. So that's certainly a slower development to really entrench that notion of linearity. We've got trend relations and reflections on the Cartesian plane. That's moved to stage 5. That's a really interesting one too, because they've done that in stage 3. Now they're not touching it at all for 2 years. And then in stage 5, granted it's in the pathways where those students might be a little bit more able to sort of catch up quickly when it's been a 2-year gap. And then we do the translations, reflections on the Cartesian plane there. So there's that. There's sort of moments like that where now there's sort of a larger gap. You just sort of need to be aware of, oh, we're doing this thing, but they haven't done it for a while. So it might take them a little, lesson or two to sort of reawaken where they were at when they left that in stage 3. And then adding into stage 4, we've got sort of just the 1 and 2 step equations, but relating with a quadratic. And then describing linear relationships in context. So that's again from a table of values or from a graph, describing that within the context of which it would provide. It's a real world applications. Broadly speaking, for measurement and geometry, we've taken out time zones, which is really interesting, gone all together. So they've done a bit of time, obviously, through stage 3, and they'll do it again when they get to year 11 and 12. I just found that really interesting, given we're in this real global community now. So it's just something to be mindful of. Doesn't mean you can't obviously touch on it when you're talking about maybe negative numbers and things like that. The line and rotational symmetry has also moved off with the transformations on the plane. And congruence has also moved over to stage 5. They brought in area of sector in the area of the circle piece, as well as the perimeter, arc length and things like that. I don't think that is going to be overly complex. It's just the use of another formula, so that should be okay. And then for statistics and probability in stage 4, there is a greater emphasis on statistics in this new curriculum. I didn't notice that on the word cloud that came up before, but certainly, and that is a reflection of the movement and the change of direction in the Australian curriculum, because of course we're looking for that convergence between the states and the Australian curriculum. And of course, statistics is just it's just more topical in everyday life now, being able to understand what's being given to you, misleading media and all those sorts of things. I think it's a good thing. I think we need to be more critical. We need to always be asking who's the author, who's the intended audience, those sorts of questions. So that's definitely a little bit more of a flavor in what's new. So talking about shapes of distributions and different types of representations. But then they've also done things like taken out other representations and taken out things like where does the data come from? So that's an interesting switch around. Let's have a look at stage 5. This is stage 5 core first. So if you sort of want to broadly think about what core is, it's sort of like that 5.1. It's that sort of base level that everyone sort of would have done. And then you could think about 5.3 as sort of covering the majority of the pathways. And then the 5.2 is sort of this middle ground between the two, some of the, so sort of an extension of core, but maybe not all the pathways, broadly speaking. So we've got what's new coming into stage 5. Royalties, which is an interesting one. Maybe they're expecting everyone to be influencers in the future. We've got compound interest again. That's an addition of another formula. So, and for a core student, some of these formulas that they've brought into stage 5 core can be pretty intense. So that's just something to be mindful of for the just the complete course students. Of course, there's the linear equations of 3 steps that have come up from stage 4, the solving equations simultaneously, 1 linear and 1 non-linear, those sorts of things. That's come down from 5.3 into core, but only with the graphical thing, which is actually quite achievable. I think there's a lot of good understanding we can get from the graphical views of some of the mathematics rather than the algebraic. Measurement and geometry, we didn't drop anything, but we threw a heap in. So into core, we've got stuff that has come from 5.2 into core. So again, you'll see here in measurement, these things just basically involve using the use of formulas and substitution. So yeah, that's just more stuff. So there's a lot more algebra work there in core than maybe they would have been used to in a 5.1 course. Statistics and probability, and just a little bit of shuffling. The back-to-back has been left out of the core, and we've got this understanding around measure, spread, causation, and association. I think they're good additions. The standard deviation as a formula for core students is not ideal, but the understanding of how standard deviation can be used as a measure to compare data sets, really powerful. And now for the pathways. So what's out? Nothing, but let's throw a heap more in. So this is what I was mentioning at the beginning. Stage 4 out of 5 seems to be more and more packed with less stuff dropped out. So for number and algebra, the key things to pull out here, we're pulling in the translations and rotations in the plane that, like I mentioned, they haven't seen since stage 3. We've got circles that have been left out of core and moved now into the pathways. Linear inequalities is completely new. We've got measurement and geometry, again, nothing out, but in the pathways, we've sort of brought in these right pyramids, cones, spheres, surface area volumes, those sorts of things, a bit of trig stuff, as well as networks. That's completely new. So whilst we're on the topic of networks, there is a bit of an overlap, and someone in the word cloud did point that out, that there is an overlap now between 11 and 12. So I suppose that's a bit of a watch this space. Now that they've released the new 7 to 10, will they do a revision on probably the standard course where I see that there's a bit of an overlap, or are they expecting that overlap to exist and be beneficial? With regards to networks, because it is completely new, we're focusing here on 7 to 10, if you haven't taught the Year 11 networks course, we actually have a PD that we offered for the standard networks course, and we can provide that as a video link to you. So if you're interested in that, you can just drop us an email and we can send you a link, and that would be really useful.
Question from me, networks is a pathway, right?
Yeah, we're in the pathway section now. Yeah. And with regards to stats, just bringing in Venn diagrams, two-way table, so nothing too extreme there. A little bit of language change, but nothing to focus on too much. So I think what you get from a picture from those slides is that they sort of slowed down some development of some areas in stage 4, and then in stage 5 they've just gone more and more and more. And it's not that any of those individual items are not necessarily relevant or necessary, but it's now we do have this feeling of, oh my God, there's so much extra. So how can we sort of address all of that? Okay, so I'm going to talk a little bit around the working mathematically stream. So you'd be familiar in New South Wales that you've always had them, and they were actually in the previous curriculum different. There was a couple of different versions of working mathematically through the years. Now there's one working mathematically stream. It goes all the way through. It's the same wording and it's consistent, and it encapsulates these ideas of the mathematical proficiencies of understanding, fluency, reasoning, and problem solving. It does use those words, but those words exactly that I have on the screen, they're from the Australian curriculums. This is another alignment that we're getting. So there's a full embedding of this working mathematically stream throughout. The standards use this language all throughout the document, and there's an expectation that these things are covered. So let's have a think about how Mathspace has handled that. What you can see on my screen here is actually just a digital version of the book. So these people have a copy of our food book yet?
Some of them might. We've started sending them out. Yeah, to any schools we visited, and then we've sent them out in the mail last week, and we'll be sending out the rest next week. So anybody who attends today will get a copy of that book, and yeah, this is what it looks like in a digital form.
Yeah. So if you don't have it, but you do have the digital version, this is a good place to point out that it's aligned completely. So what I'm currently in is 505 divide decimals. I'm in the question page. It starts with this understanding question with a short division picture, and you'll see exactly the same thing here on the screen. So it's 1-to-1. So students come in, they don't have a book, that's okay, you can jump online. Oh, you don't have your charger, that's okay, here's a book. So it's completely exactly the same. So we're looking at every section in our book where we've embedded the mathematical, working mathematically stream and those mathematical proficiencies. So every section in the book has these sections: understanding, fluency, reasoning, and problem solving. They always have questions, and so there's not sort of some sections that don't have reasoning. All sections have all 4 proficiencies. So what are these 4 things, and what questions can you expect within them? So an understanding question does pretty much one of 2 things. It is, what is the prerequisite knowledge that a student needs to have to be able to show success in applying the concept that we've just learned. So we're looking at dividing decimals in this particular example. So you'll see there's a question down here around estimation. So we're using our understanding of whole number estimations to be able to apply that then to be able to estimate decimal values. So being able to divide using whole numbers and then sort of extend that one step further. The other sort of idea of an understanding question is basically what I just say is it's the what's in the box. So you'll be familiar with textbook structures where they have a little summary box at the end that sort of encapsulates the important ideas. Imagine if you're standing at the front of the classroom, you've done your little spiel, and you turn and you look at your class and you sort of just want to know, have they been listening to me for the last 15 minutes? What are you going to ask them? How do you know that they all know that we're on division? How do they know that they're all talking about place value and its importance and where the decimal place will go when we're dividing decimals? That's sort of what an understanding question is. Fluency question, we don't need to go into that too much. That's the basic do. It's the one-step application of the concept in question. Textbooks are full of those, so we've obviously got a nice rich fluency section. A reasoning question is one that goes a step further than that. Can they explain how they did their fluency question? Can they explain why? Can they sort of error correct? If I show you someone's working, can you follow it? Can you understand it? And can you identify where they made a mistake? And you can do that in your class, of course, just side by side, swap pages, and you have a look at each other's work. Did they both get them right? It's also things like being able to identify patterns and apply that. So you'll see there's a question 14 here that does that. I could zoom in. Oh, I can't zoom on. Just one. Anyway, you'll see there that there's a pattern question. We sort of provide them with something that they can then apply that pattern in different ways throughout the question. And what was that? Reason, explain your thinking, justification, pattern identification and stuff like that. And then problem solving is what my team call like complex unfamiliar. So it's more than just the one-step application of the fluency question, of the concept. So it's more than the fluency, it's a little bit more than that. So is there something that's a bit unfamiliar about it? We try and have a question in each set that combines something from somewhere else. So in this case, we've combined the idea of perimeter. So it could be something from the previous grade or previous stage, or something from earlier in grade 7, something like that. We want them to be maybe multi-step. They could be extra information that they sort of have to decipher which is the important information I need to solve this question. They're the sorts of things that you can expect in problem solving. It doesn't just mean a worded question. You'll see in questions over here in questions 12 and 13 in fluency, one-step application of the concept in words, still fluency. But yes, problem solving is definitely more literacy. So that's important to note. We'll talk about some other aspects of the question sets. Importantly, the differentiation pathways that we have here. So we have, you'll see here on the screen, we've got Explorer, Adventure, and Trailblazer. Broadly speaking, you could think of it as like easy, medium, and hard. And that is so that on the fly teachers have an ability to differentiate in their very broad ranging classrooms. So recently, in the most recent PISA research, they said that in an average Australian grade 9 classroom, there is a 7-year gap between highest and lowest students. That's on average. So that's huge, right? That's massive. So you've got to be able to think about, oh, I've got students who are operating, you know, on basic whole number calculations, and I've got students who are operating and they're trying to, you know, extrapolate this into algebra because that's what they want to play with. So we're trying to find a way that on the fly very quickly you can say, oh, in this particular case, you can do the Explorer pathway. In this particular case, do a Trailblazer. What's really important to me in this is that every single pathway still has 4 proficiency strands. So just because you're an Explorer doesn't mean you can't problem solve, reason, or understand. So it just means you might do it in a different way to a Trailblazer. So if we just pick out one example, so for example, question 20 is Trailblazer only, and that is this problem solving question over here. So you'll see that there's multi-parts, high level literacy, we're combining other concepts here, probably multi-step as well. So that sort of puts it into that higher level of accessibility for use for year 7 student.
Yeah, I know that's been one of the challenges for the team, is to like come up with good examples of problem solving and reasoning, both to challenge the higher levels, but also that even the lower levels can engage in some basic reasoning and basic problem solving as we go through. So effectively what we've tried to do here is like the question sets are quite rich, and there's a lot of them. It's very comprehensive, but we don't necessarily want everybody to do every question. And so hopefully by doing these pathways, we've made it a little bit easier for you. I know a lot of teachers, as I've been kind of going around to schools and showing them what we've done here, is they're like, that's exactly what I do. So there's a lot of change coming. So if we can help take a little bit off your plate by selecting the kinds of questions that you might want to assign to different cohorts in your class, then that's effectively what we've tried to do there. And and you can do that knowing that you're still going to get that reasoning and problem solving exposure to the Explorers, and you're still going to get the understanding and fluency to the Trailblazers as well.
The other thing that's important to note is that across all of the proficiency strands, all 4, there'll be a common question that all of the different pathways will do. That's so it provides the teacher an opportunity. You can see here that in the understanding question, everyone will do question 2. It gives the teacher an opportunity to address the entire class and know that regardless of which pathway they are on, they all would have looked at that question. Yeah. Just pausing to think if we cover everything there. Okay, so other key changes, and there was a little bit of this on the word cloud as well in terms of the higher order thinking skills, the more in-depth stuff. So this is sort of, if you like, you throw it in the STEM thinking bucket. So rich tasks, open-ended things, investigations, all that sort of stuff. I've got to mention, what's the time, by the way?
Halfway.
Okay. I'll just quickly mention the New South Wales Curriculum Review has this document called, if you want some stimulating nighttime reading, it's the, oh, they've moved the link, of course they have. So there's this document, I'll have to dig it out now, but there's this document called, oh, I've got a picture of it, Community Aspirations, where they talk about obviously what it is that they hope their new curriculum will do for future members of our community. It's very long. It's basically just pages and pages of text that look like that with no white space to break it up. It's very hard to read at night. So, and maybe they're just winding glasses now. But but you'll see some keywords here, and this is what I want to point out. The bolded words, I've just chosen this bit: digital literacy, problem solving, critical thinking, creative thinking, communication skills, those sorts of things. Why is all that there? And I'm just gonna, yeah, that slide, of course I did. That's because we've got alignment with the Australian curriculum. The Australian curriculum calls all of these things general capabilities. So it's exactly the same. So they've just thrown it in this other random place called community aspirations. But basically what we're saying is all of Australian students, whether you're doing the Australian curriculum or the New South Wales curriculum, we value these things. And I think as mathematics teachers, we do value these things. And these are also part of what allows us to engage with these higher order thinking activities, which I mentioned more, like the words like modeling and investigations and simulations and things like that. So there's a lot more of that sort of language in the new curriculum. Something that often comes up when I talk to New South Wales teachers about the new math curriculum is this, it feels like a juxtaposition, right, between we want to do more of this higher order thinking stuff, we want to do more of the skills. And when you look at the media statements, they say, oh, our new curriculum, and the Australian curriculum did the same thing. Our new curriculum is going to improve our international numeracy results because we've got numeracy improvement and we're going back to basics and looking at skills. And you sort of wonder, how can I do both at the same time? And that's because as teachers, we're magicians. So, but we're going to try and help you support that to be better magicians. So let's think about the higher order thinking things. I'm not going to go into this into too much depth. It's just as an example. But if you just go away and you Google mathematical modeling, and you click on the image bit, you'll see lots of pictures that look like this, little flow charts, how to think about higher order thinking in some sort of a real world context, because real world is mentioned a lot throughout the new curriculum as well. There's definitely a new emphasis there. I like to break it down into 4 steps. I think that's a bit manageable. And when I was teaching, it was something I could always keep at top of mind. So it's basically the same thing, except for we're just going to do it in 4 steps. What is the problem? What is the real world problem? Can I construct a model around that? So that might be, can I go and collect some data if I'm doing statistics, or can I come up with an equation so I can, model this taxi hire flag charge thing that everyone likes to talk about, which, we don't even do these days because we have Uber. Can I analyze it, right? And so that is, you might iterate here, you get feedback, you might refine the model, and then interpret the answer in context, like go back to the beginning. Did this work? Did it do what I wanted to do? We can do this from a modeling perspective, just like in terms of, we could do it with algebra, with functions. We can also then layer a statistical inquiry process over the top of this, and then you just put statistics in it, collect the data, do something with it, visualize it, still interpret the answer in context. So there's statistical inquiry, it's the same thing. So let's talk about how we've done that to help you in your curriculum journey. So, that was this. I don't need that. Okay, there are 2 main ways that we can do higher order thinking. The first is, actually I might do this one, through an investigation. So an investigation does the full cycle: formulate, construct, analyze, and interpret the answer in context. An investigation is like a multi-day or multi-lesson, or maybe you do it Friday afternoon or Monday morning is STEM day, it doesn't matter. But it's something that they do and they come away and they go back to it, they bring fresh ideas and they sort of continue to work on it. And they'll work through that full cycle. The full cycle, if just left alone, and you may have done this before in the past, you may have just given year 7s this open-ended assignment and you wonder why they sort of don't know what they're doing. And that's because we sort of haven't structured this modeling process to them. So our investigations are here to help you with that. In the book, you'll see here, I've just searched for investigation on the left, and all the investigations we've got in grade 7 have popped up. So these are just all the different sorts of topic areas that we've got investigations in this particular New South Wales grade 7 book to help with this open-ended modelling sequence. We've got some steps here. There'll be reflection at the end, some discussion questions. So we sort of loop right back to the reflection, interpret the answer in context, or open up the ideas to what could you do next to go around the cycle again. So that sort of helps with the full cycle, but you don't have to do the full cycle all the time. You can just do one part of that. So if we can keep thinking about that 4-step process, we can just think about one of those 4 steps. And so to that end, we've got what we call explorations. So within the lesson content, we've got these little explorations. So in the, that kind of worked and went crazy. In the textbook, you'll see this little blue box that says interactive exploration, go online to do the thing. That's because this particular one has an interactivity. The interactivity for that particular lesson is this section here, volume of a rectangular prism. An exploration is something that is self-contained. We try and write them so that they will take a teacher or a group of students, maybe 15 minutes. Some ideas on how you might use that. It might be that you project it up on the classroom board and you can have a class discussion. You could project it up, but then bring small groups through during the lesson. So you can have sort of more personal conversations with groups of students, or maybe they can all open it up on their devices. They can do a pair share, work through the questions together. So the explorations are here sort of to focus on one of those 4 elements each time, about 15 minutes in length. The interactive ones are obviously interactive, and we'll have to point you to the digital product. There are a few non-interactive ones as well that just have the questions. The questions are here to sort of lead students towards the concept that we want to uncover and talk about more formally. Anything to say on that before I talk about the teacher?
Just a couple of points to give you an idea of the scale of this. So you saw with the investigations, we've aimed for about 1 per topic on average. And it's not 1 per topic because some topics are like really good for investigations, like statistics, and some like algebra, generally not so much, where it's a bit more formulaic, and fluency is kind of a bigger part of it. And we've also worked on, so that's with the investigations, that's with the full cycle that Erin was discussing, where you might, spend an entire lesson or even 2 lessons on that full model. With these explorations, we've gone for a lot more, where it's like these smaller kind of, can be like a 10-minute thing that students can visualize the math. We mentioned, Erin mentioned that some are interactive, but also we have a lot that are non-interactive. So we kind of wanted to make sure that there was a mix where it's really suitable to visualize the mathematics and use that interactive, then great. But because not everybody has access to digital, and there's still many explorations where you don't have to actually, they're not necessarily, you need everybody on a device to do. But there also could be just great where you just have just the teacher projecting to the class with those interactive explorations as well. So on the scale of this, because they're kind of shorter, 10-minute things that you can run through, we've aimed for a lot more. And I think we're saying on average, it's 1 every 2nd subtopic on average.
Yeah.
So there are a whole lot of opportunities for this kind of critical thinking and modeling embedded within the textbook that don't necessarily require you to take heaps of time to do. You can do a short 10-minute thing where you're practicing that real-world applications, the modeling, the critical thinking.
And each time students experience more and more of these explorations, it's good preparation for them to go off and do the full modeling cycle. While we're here, we'll talk about the teacher notes. So on the digital product, there's a little teacher guide that you can switch to here. This is new for next year for these new books.
Can you blow up the screen just a touch?
Yeah. Is that better?
Is there a Control-Shift+ or something that you can do? Yeah, there we go. Okay. Yeah.
So on the teacher guide, if we scroll down to the same section, the exploration section that we had up just before, there are ideal student responses. So as to those questions that we had on the front page, what is it that you're looking for students to say? Now, experienced math teachers, they know these things. When they ask a question, they already know what the answer is that they're looking for, and they're waiting to hear that. And when they hear that, they can go, yes, and now tell me more, or what next, or explain that another way, so that we can sort of elicit the real understanding from the students. So there's some sample ideal student responses here. So that is a reminder for the experienced teachers, but also we all know that we've got a lot of teachers in our schools that are actually teaching out of area. So this gives them guidance. What am I looking for students to say? And I can pick on those correct answers to sort of pull to the group. We have purposeful questions, which is something more overarching, so you can have more open-ended discussions following your exploration. And also, really importantly, those misunderstandings. What is it that they might say that might be incorrect that I want to be able to pull up straight away and say, hang on a minute, let's correct that misunderstanding or misconception. So again, a useful reminder for experienced teachers and really valuable supports for those who are new or out of area. Our teacher notes also have lesson supports. All of them will have 4 There'll be a reminder about a useful targeted strategy that you can use to help actually do some sort of exploration. So that might be with hands-on materials, or it might be through some kind of, what is this particular one? Yes, this is with like a hands-on one to help them think about the ideas. We've got English language learner supports and students with special needs, and some accommodations that can be made for those, as well as, again, misconceptions for the actual concept at hand. So this one has what's one of the most common things that students are going to sort of trip up on, and you can sort of pull that out as well. So that's every single section across 7 through 10 will have a teacher guide. If you've been using the primary products, you're already familiar with them because they've been in the primary for a couple of years. So that's the exploration, the opportunity to practice a small part of that modelling cycle, leading to the full investigations where they can then go off and explore that more rich, deep, open-ended stuff.
Yeah. We do a little, we're getting a couple of questions. We'll do a quick break to go through some of the questions. Melissa Hill asked, will textbooks be available for all years 7 to 10 for the start of 2024?
Absolutely. They'll be ready, what do we say? September, October.
Yeah. So term 4 this year, actually. We wanted to give everyone the opportunity to take a full look at them before they make their purchase decisions for next year. Obviously, the new curriculum, a lot of people, it's a great opportunity to check out what's out there. Maybe it's if you are thinking about new textbooks and changing your textbook, this is the right time to do it. And we want to do that. We give you everyone plenty of opportunity to do that. So Erin has been a DDB working through this. But yeah, so you will receive a print copy of your year 7 book next week. Like, that's all ready to print. Grade 8 will be available digitally. Is already available digitally. So if you have a digital subscription, you can actually navigate by changing textbook. Yeah,
just here on the textbook page, there's a little change textbook button, and you may never have clicked it, but click it. And then when you click it, you'll see all the textbooks that are available to your school. And this is one of the great things, is that when you get Mathspace, you don't just get the one book, you get all of the books. So you'll have 3 through 10 here. And then you'll also have the new 2024 7 and 8 on your bookcase. If you don't see it, just let us know.
Yeah, look for 2024 for the new curriculum.
Yeah.
That leads us into Samantha's question. Will there be additional resources, questions available online for extension work, or just the online version of the print textbook? You will have access to all the textbooks. We never gatekeep our textbooks. If you purchase a year 7 textbook, you have access to grade 3 right up to grade 12 of so you can have those students in year 7 and extend them with all the online content. Yeah, so that's there's a lot of online content that you can extend with from other grades as well. I think Greta asked the question just to kind of compare so that people know what's on digital and what's on the print. So student lessons are a one-to-one match. What you see there. Where you see something that's an interactive exploration, we call that out as interactive.
If you just go there.
There we go. So we call that out as interactive. The questions are still printed there, so you can kind of get a sense of like what this is all about. And if you think, hey, that's really cool, I want to get my students to engage in that, then you can jump on and do the interactive, whether that's every student's doing it or you're modeling it on the big screen. And everything else you can see is an exact match. One thing that we have extra, so work solutions we hide by default, and you can show them video walkthroughs. So every single example has a video work solution with a teacher annotating on the screen. So that's something that's digital only. Again, so it's exact same questions, but that's a digital only component. Yeah, here's another example of an online investigation. We're looking at volume, online exploration, sorry. Okay, the teacher guides that Erin looked at earlier, that's a digital only thing. So they're obviously not printed, they're just there for the teacher. And then when we get to practice, there are 2 types of practice. There is your adaptive digital questions, and there are your worksheets. Now, there is some overlap, but not total overlap amongst these. A lot of the fluency questions will overlap.
He's not talking about, that is a one-to-one with the print book. It's just not going to overlap with the adaptive questions.
Correct. Sorry. The worksheet is an exact match. So you'll see the understanding, fluency, reasoning, and problem solving. So this is just a digital representation of what's in the book. basically means if you have digital and you are digital ready and you're one-to-one, there is no reason to purchase the extra book. We don't, we're not kind of, you know, pushing people to purchase the book if they don't need it. It's a totally optional thing. Anyone who does have a digital subscription will get access to the books. You do have to be on the Schools Plus package, and you can talk to your local school consultant to just see if you're on that package where you have access to all the digital, the full textbook digitally. And then the adaptive questions, that's where the digital questions are. So these are not exactly the same as things. So there's always kind of extra support, extra opportunity to extend over here, some extra fluency questions as you go through. Certainly the worksheet questions will have more of the reasoning and the open-ended problem solving because they are difficult to do in a digital realm, and part of the reason why we created the worksheets to make sure, and the books, to make sure that we have these opportunities to test the full extent of the curriculum. So you won't get the full coverage in the adaptive, but there's a lot in there. There are also questions that we're adding into the adaptive. So one of the things that we've done is problem solving, as you saw, is now incorporated into every single subtopic. There is reasoning and problem solving, whereas some of our adaptive questions used to have a separate topic on, you know, application problems. So we're doing the work of building those and moving a lot of the application problems into there. So if you don't see the full extent of the problem solving, that's work that's being done to ensure we have the full coverage of problem solving in the adaptive sets as well. Yeah. Okay. So hopefully
the other thing that would be digital only will be the work solutions as well. That will only be digital.
Yes.
Yeah.
So
we don't have them on the screen at the moment, but full work solutions for every single question through the entire series of books.
For teachers only.
Yes.
So students will have the answer keys and they can just get the final answers only. One thing that's interesting is with our answers is we don't just say kind of answers may vary. We always give a model answer on all of these. That's been well received, because I think a lot of people are used to not having this kind of detail in the worded problem answers. So we have the one possible answer as we go through. And yeah, the full work solutions will be coming for teachers only. We don't want the students to have the full work solutions.
So that means you're never sort of caught out, right? So you sort of, I remember doing that sometimes, or being called into classes with teachers who are teaching out of area, and a student had worked ahead and had done a different question to what they'd prepared, and they sort of didn't quite know how to address it. But full work solutions will be there to support you.
And we did have a question about somebody, Michelle said that she loves the pathways, the choose your question path.
Yeah.
Currently, that's not in the digital product. We will be adding it.
Yes.
So we will be adding that over here. So you don't need to kind of click back and forth between your textbook. So yes, you will be getting that inside the digital product as well. We've done that work for you. Yeah. Great.
There we go. Good questions?
Yes.
All right. Okay. Why did it do that?
Kate asked again, she missed what was happening with the Year 9 and 10 2024 textbooks.
Oh, yes.
So 2024 textbooks will be available early term 4. So you'll be able to see everything before you make your decisions for next year.
Yeah. What we do have before then, if you wanted to see sort of scoping, is we have this document that I've got here. This can be shared with you. It shows you basically the topic and subtopic, like the chapter set makeup, sort of what's going to be in each chapter and which area of the curriculum it covers. So you get a real feel for how we split up that 9 and 10 content. And you can also make an appointment to talk with one of our people who can take you through the book, and they can show you the pre-release, and you get a good feel for what this is basically just being built. So it changes regularly, but you'll see the structure, and I'm going to talk about that in just a minute, actually, with 9 and 10. So this is one of the biggest changes, of course. We're taking 5.1, 2, and 3, and we're going to a core path model. So what does that mean? So this is straight from the NESA document. The structure is intended to extend students as far as along the continuum of learning as possible and provide solid foundations for the highest levels of student achievement. The intention behind this, I believe, is really strong. It also matches with the new intention of the new Australian curriculum and moves in curriculum around the world in terms of let's not gatekeep interesting content that could inspire people to want to do further mathematics study to just those that have been already funneled into a high performing class. So the intention here is that we're going to have stage 5, we're going to have classes of students, and all students in there will have the opportunity to be extended as far along that continuum as possible. So that might mean that for some stage 5 students, they basically do core and dip their toes into a couple of pathways at points to see if they're ready. It might mean at the other end that you have a large groups of students who sort of start further along stage 5 and go much further into a lot of the pathway options. And then there's anything in the middle where you might have some students who generally are sort of core students, they're doing the core work, and then they get to the end of the chapter and they're like, oh, I can do that next bit. I'm really getting this idea of volume, what's next? I'm really getting this idea of functions, what's next? Oh, let me see a circle, those sorts of things. So I'm going to show you, so the idea is that most students is to demonstrate achievement of the core and then as many pathway outcomes as possible. So, you know, core is gold. You want to make sure that everyone has this solid foundation and then identify who's ready, willing, able, and then take them as far as possible down that pathway. The biggest question is, how do I do that in a class, of course, because I'm going to have a classroom of students, and what you're telling me is that I need to be teaching 30 individual learning pathways, and that's kind of the intention. And they just say that we need to be flexible. That's NESA's guideline there. Their keyword is, you know, again, teachers are magic. So how can we help you with that? Let's have a look. I don't have the beautiful print flip book for that because it's not quite built, but I wanted to talk about 9, 10, the structure and the pathways. So across 9 and 10, we've split the core so that there's enough core work for a core-based student through both 9 and 10, really important. We didn't want students getting to grade 10 and not having core work or just being expected to repeat the entire core again. So we've split that core up across 9 and 10. When we get into it, you'll see that all of the sections in the book for stage 5, well, that's a bad one because it's not built yet. Let's pick a different one that's got some content. This one, surely. Anyway, look at the structure. That's probably more important. The C's here are core. So this is all part of the core work. You'll see that there's a core reference to the New South Wales curriculum there. And then at the end of every topic, there is these often opportunities for pathways. So we've got, okay, we've been doing this thing, it's core based. We've been working on linear graphs and equations. And then at the end of that, we've got, oh, there's some pathways that are related in terms of other forms of the linear equation. So this is like looking at the general form and the 2-point formula, stuff like that. And then we've got rates of change, which is a pathway as well. So we've got core and pathways. So you've got the ability in a classroom to have the one reference, the one resource, whether that's digital or book, and have students work through that sort of chapter as you're going, and then you can extend where they're ready to be extended. Some chapters are made up of entire pathways. So, and we put the little P there, so it's just a bit of a reference. So if you've got core only students, there's no core work in this particular chapter for you. I probably don't have content in there for that yet. But you'll get the idea. So it's really important to see that we've got pathways and core, and that it's really easily identifiable from the outset. What else do we want to say?
So importantly, we built this all into one book.
Yes, there's the 10 one here.
Yeah.
You're talking about that.
So we haven't kind of got these as like 2 books. There's like a pathway book and there's a core book as we go through, and that was like really intentional. It's going to make the books quite thick because there's a lot of extra content, as Erin has noted, and a lot of content is new to stage 5. But we think that that's the best way to really achieve what we're looking for with, you know, making this pathway content optional and things that someone can really kind of dip in and out of, where you don't have to cover all of it, but you can cover, which is the intention of the curriculum. So
yeah. And they don't have to do the entire pathway either. So just because a pathway might be mapped, so for example, transformations of exponentials is related to this particular pathway, this NLIPO1, just because you might want to expose some students to this particular part because they might really understand translations and you want to apply that to the exponentials because we're doing it and they seem to be engaging with that really well. Doesn't mean you have to go off and then do all of the rest of the pathways for NLIPO1. It's about as many opportunities to be experiencing those. So like I said, dip your toe in the water. Are they ready? Oh, great. Let's see what else is in that particular pathway option. So we sort of held true to the intention of the curriculum there. It also means that, you know, all students get to see all of the mathematics. And that's one thing I really think is powerful. Like, there are students who get to the end of high school, and I used to see this all the time when I was teaching. My last school was 11-12 only school, and we would go to visit the year 10s, and you know, we'd have teachers give us their results and say, here are the students that you're getting. And, you know, or they'd want to see what they enrolled in. Oh, no, those students can't do methods. But, you know, there's a real maturity switch that can happen between 10 and 11. And we used to see that all the time. They come to year 11, all of a sudden they've got a better clue about where they want to go or what they want to do, or some level of maturity and application to their ability to practice and consolidate their mathematics. So it means that we're not writing any student off. And that's a real big intention from the NESA stuff, is that everyone gets an opportunity to see it and to experience it. So it also means that they don't get written out of the stage 6 courses, and it's not dependent on these. It's just good preparation for. It doesn't mean that they can't engage with it later. So they're not prerequisites. Yeah. Any questions on that?
Lots of questions about just getting access to stage 5.
Yes.
Obviously, it's top of mind for a lot of New South Wales educators right now, with a lot of schools looking to implement grade 7 and 9 next year, some kind of going all the way. So a question about a beta version, when can they kind of see a work in progress? So what we can do from now, what we will do is share with everybody our draft programs. So we're not ready to share it entirely, just because we are still, yeah. So we are still changing things up and finding things where it's like, you know, those two subtopics are better combined, and this one's probably a bit, you know, we'll split it up into 2. And, you know, even in those kinds of decisions are still being finalized. So we don't want to kind of thing, but I know it's so helpful for people to just have a look as they're writing their programs, and teachers are stretched. So if this is helpful to just see what our structure currently looks like, noting that it is draft and it is subject to change. So don't go too far writing your programs on this.
Don't be matching things to 1306C just yet, but you can certainly go topic 13. And then in terms of a beta release where they can actually get their hands on seeing the content digitally. I'm not going to hold you to it. Whatever we do, if you want a number from Erin right now, let's stop the recording.
Let's promise not to hold her to this.
Let's say digitally, like, should be able to do that within 4 weeks.
4 weeks. Again, we won't. Just so that everyone can kind of get a sense for what that content looks like. But, you know, we won't be printing that version because we'll still need to do a lot of the thorough quality assurance checking. So before we get to the levels where it's kind of ready for print. But in 4 weeks, we should be able to kind of put something in front of you so that you can start to see what this content looks like. And we know there's a lot of decision making that you need to do right now. So hopefully,
it can help with your planning here too, because you'll see here we've got some estimated timing. So for this particular topic 13, we're in stage 5. You'll see here that this chapter is made up of core and pathways. It's about 2.5 weeks of core work. And if you had students doing all of the pathways, there's another 2 weeks of work on top of that. So all up, if you're going to do it all, it would be 4.5 weeks, which no one would, because if they were going to do all the pathways, they'd probably start further along the core anyway, because they would have already demonstrated some of this pre-existing knowledge. So that's more of a switch probably. But yeah, that can help with your planning. So
on writing programs and scope and sequence. So this is the document that we can share with you, which is you know, just expected times. But you want to talk about how we order the content, that it's not necessarily a scope and sequence.
So in all of the books we do it in a predictable way. So we sort of tend to go the first half of the book is your number and algebra. In the middle, you've got your measurement geometry, and at the end, you've got your stats probability. So it's not a teach from chapter 1 through to chapter 13 thing. Otherwise, you'll never finish stats. So we want to make sure we make that really clear. But it means you can always find where your content's going to be. On doing stats is going to be at the back of the book. So that's one thing that we do, and that's across all the books that we do in Mathspace. But within a chapter itself, it's definitely sort of conceptual development, as linearly as you can sort of get when you're talking about mathematics, which is more of a crazy fun network. So you would expect that you would sort of experience these things in order. But it doesn't mean you have to do all of chapter 1, 2, 3, 4, and 5 before you do chapter 7. So
yeah. And you obviously have a lot of flexibility of like, okay, you've done chapter 1. Do you want to tackle the pathways now, or do you want to kind of come back to them to make sure that you get through your core first, or all those kinds of things? Hopefully the key labeling with that document on how much time you might spend on each will just help you to kind of, so it won't write the program for you and the scope and sequence for you, but it gives you everything you need to do to make that pretty easy. And then of course, all the teacher guides that we have in there. So the subtopic overviews, where we have the learning objectives, and all the teacher notes can help you really flesh out your programs. So we have that for every subtopic, and the topic overview as well. What are the big ideas that you're teaching to? So in terms of like writing programs, a lot of what you'll need is already there. We haven't written the program for you, but we've given you the kind of tools to be able to do that.
Yeah.
Hopefully make your life a lot easier.
okay. What are we going time-wise?
We've hit time, so we'll do any final questions, and then if anyone wants to stick around, we can show you some of the latest things. I hope what you've seen today is that we do have this best of print and digital. A lot of you who are familiar with Mathspace will know all the things that we do at Mathspace above and beyond just the question sets. One of the big things I'd like to point out is what we've shown you today is a textbook view of Mathspace, and a textbook view is really taking a slice of the curriculum that, so we're going to do just this part of data and this part of chance and this part of number and place value and this part of real numbers in grade 7. But really the curriculum as a whole is, it's kind of a little bit arbitrary, like that's what we're going to do in year 7. What about if students have gaps in prior grades? How do you kind of address that? So one of the big things that we do at Mathspace is we say, well, if you're teaching grade 7 patterns in algebra, it's actually a great time to look at that skill holistically from grade 3 up to grade 7 and maybe even extend to grade 8. And this is a skills view in Mathspace. So for those who haven't seen Mathspace, our vision is to kind of have this combination of looking at the textbook view and teaching grade level content, but always giving students the opportunity to fill in their gaps in their learning. So that's something that we have in our skills map. So here's a student that's in grade 10, but they're able to see that they have some gaps there in grade 8 and grade 9 and grade 8 and grade 7 in number. So they're able to kind of own their own learning in their journey towards filling in those gaps. So that's something that's worth looking at in Mathspace. It's not just one thing. Like I said, we don't gatekeep. So students won't even know they're working on high grade level content because they're in the skills view. That's something that's important to us. And yeah, so we're kind of looking at this. This is what we believe is kind of the best way to put students to be exposed to grade level content in their textbooks. So they're working with their peers on grade level work, but have that opportunity to catch up, and that kind of moves. So not be overwhelmed by all their gaps, but just over the next 3 weeks while we're doing patterns in algebra, you can focus on your gaps as well. Okay, I'll look to see if we have any questions. Will there be a video of this presentation available? Yes, this is being recorded, so we will share that with you. You can share with your colleagues. Great. Any other questions coming? Get a copy of the recording. Yes, we'll share that. All right. A lot of thank yous to Erin. Thank you so much, Erin, for all the work that you do.
Thank you for coming.
Okay, I think we've got all the questions done. All right, a lot of thank yous. If anyone does want to hang around, a little kind of teaser of something that we've been working on over the last 3 or 4 months. Milo, our AI chat tutor. So the ability for students to ask questions inside while they're working on a question in Mathspace. So this is a really exciting feature for us. We're using AI, we're using ChatGPT in the back end to do this. A lot of the kind of initial talk of ChatGPT has been around, how do we stop students from cheating? When we look at ChatGPT, we're like, how can we make it easier for students to learn so that they would never want to cheat? And so this is a really exciting feature that we built into Mathspace. Basically, in addition to the hints and videos and steps that students can ask in Mathspace, they can also just type in any question they have on that question, and they'll get some really specific help on the questions as they go through. So it's just an example of that in action. So if anyone is interested in taking a look at that, it's now in beta. We're releasing it free for the rest of this year for anyone who wants to give it a go. So if you are a Mathspace user and you want to, just reach out to support and ask them, hey, can I turn on that fancy AI chat thing that Mo and Aaron were talking about? Yeah, also, if anybody wants access to the digital, so we'll be sending the textbook to everybody who attended today. If anyone wants access to the digital versions, you can come in and see that interactivity that's involved in Mathspace. We're happy to set everybody up with a free trial to explore the new content and explore that interactivity along with their students. So just reach out to us. I think you will all get an email with an opportunity to book a time for with a consultant to take you through things and to spend 15 minutes talking about what's the best way to set up a trial for those that want to do that. Will the Milo chat help make the hints more student friendly? Absolutely, yeah. Greta. You are a prime candidate to be testing this out, Greta. Yes, we would just confirm that you have permission to turn that on, and we will absolutely turn that on for you. I'd love to see how your students feel about that. Okay, thank you, Samantha. Okay, Greta, we will turn that on for you. Yeah, look forward to your feedback. All right, thanks everyone.
Thanks everybody.